Hello मेरे प्यारे बच्चों, welcome back. I know, exams are just around the corner and the pressure is really on. But don't you worry one bit because your favorite tutor is here to make everything super simple for you. Today we're going to tackle one of chemistry's most important chapters, the periodic table. And you can just forget those boring textbook pages, okay? We're going to understand this chapter like it's a fantastic movie, with its own heroes, some crazy plot twists, and of course some awesome cheat codes for your exam. So, are you ready? Let's dive right in.
Okay, just imagine this for a second. Imagine your room is full of clothes just thrown everywhere, shirts, pants, socks, a total mess, right? How would you find your favorite t-shirt? It'd be impossible. Well, that's kind of what chemistry was like back in the 1800s. Scientists had discovered over 100 elements, and the list was just a chaotic jumble. No order, no system. How could anyone possibly make sense of all that?
But here's the best part, Bachon. Tension nailinnica. The goal here is not to memorize the names of all 118 elements. I mean, who could do that? The real genius, the real magic, was in finding the hidden pattern inside all that chaos. It's like finally organizing your clothes into different drawers, one for shirts, one for pants. So the main point is, we don't have to remember, we just have to understand the beautiful system behind it all.
So, before we got that perfect organized wardrobe, there were some early attempts. You can think of these as the first rough drafts. A few brilliant scientists looked at the mess and said, okay, we have to fix this. They were the very first ones to try and bring some kind of order, to start grouping the elements together. Let's meet these pioneers.
First up, you had Döbereiner. He made these little groups of 3, called Triads. It was a pretty smart start, but it only worked for a few families of elements. Then came Newlands, and he had this cool musical idea. He noticed that properties seem to repeat every 8th element, just like the notes in our Indian music, Sa, re, ga, ma, pa, da, ni. He called it the Law of Octaves. It was a beautiful idea for sure, but it kind of fell apart as more elements were discovered. Good tries, but the main hero of our story was yet to arrive.
And then, the main hero of our movie enters the scene, Dmitri Mendeleev. He was a Russian chemist, an absolute genius. He is the one who finally created the first really powerful, useful wardrobe to organize all the elements. This guy gave us the first proper periodic table that literally changed chemistry forever.
So, what was his master plan? Well, it was such a simple but brilliant idea. Mendeleev's periodic law basically says that if you arrange all the elements in the order of their increasing atomic weight, their properties start repeating themselves after certain intervals. So he put them in a table, arranging them so that elements with similar personalities, like all the superreactive metals, would fall into the same vertical column or group.
Now this is where it gets really interesting. This is what separates a hero from a superhero. Mendeleev was so confident in his system that when an element didn't quite fit, he didn't try to force it. He bravely left an empty space and basically said, hey, an element that belongs here hasn't even been discovered yet. And he even predicted its properties. Look at Eka aluminum. He wrote down its future atomic weight, its density, everything. And guess what? Years later, when gallium was discovered, his predictions were almost spot on. I mean, how mind-blowing is that?
So Mendeleev's table was a blockbuster hit, but, it had a few minor issues, a few plot holes. The perfect director's cut of the table came from a young scientist named Henry Moseley. He's the one who gave Mendeleev's table the final ultimate upgrade by finding an even better way to organize the elements.
And this right here, this was the big twist. The modern periodic law is not based on atomic weight. It's based on the atomic number, which is just the number of protons. And you know what? It's a much more fundamental property of an atom. When the elements were arranged by their atomic number, Bachon, it was like magic. Every single one of those little problems from Mendeleev's table just poof, they vanished. Everything fell perfectly into place. And here it is, in all its glory, the modern periodic table. This, my friends, is the ultimate cheat sheet for every single chemistry student. Just remember 2 simple things. The horizontal rows, like the rows of desks in your classroom, are called periods, and the vertical columns, which are like teams with players who have similar skills, are called groups. Simple as that.
Okay, now let's quickly look at the table's layout. Think of it like a map of a big city. This city has 4 main neighborhoods, or blocks. You've got the S block, the P block, the D block, and the F block way down at the bottom. An element's address, which block it lives in, is decided by its electronic configuration. And just like an address can tell you something about a person's neighborhood, an element's block tells us a lot about its chemical personality.
All right, time for a quick pop quiz for my brilliant students. Elements in the same group, like lithium and sodium, they're like siblings. They behave in very similar ways. So why is that? It's because they have the same, what do you think? I'll give you a second. It's the same number of valence electrons. Those are the electrons in the outermost shell. It's almost like they all have the same Instagram bio. It defines their public personality and how they're going to react with others.
All right, bachcho, full focus now. This is the most important part for your exams, okay? We're about to learn the secret patterns, the cheat codes of the periodic table. If you can understand these trends, you'll be able to predict the properties of any element without having to memorize a thing. I promise you, this section means guaranteed marks.
So, our first cheat code is atomic radius. In simple words, it's just the size of the atom. That's it. Now, because atoms don't really have a sharp boundary, the way we measure it is by finding the distance between the centers of two bonded atoms, and then just taking half of that distance.
So how does the size change as we move around the table? Well, have a look at the trend. As we go from left to right across a period, the size of the atom actually decreases. Surprising, right? It gets smaller. Why? Well, because the nucleus is getting more positive, so it's pulling that same electron shell closer and tighter. But as we go down a group, the size increases. And that's easy to understand. We're adding a whole new electron shell with each step down, kind of like adding another layer to an onion. Okay, cheat code number 2, ionization enthalpy. I know it sounds really complex, doesn't it? But trust me, it's simple. It's just the amount of energy you need to snatch the outermost electron from an atom. Imagine your friend is holding a 10-rupee coin. How much energy would it take to snatch it from them? If your friend is very strong and stable, it's going to take a lot of energy. It's exactly the same for atoms. And this graph tells the story perfectly. Just look at the highest peaks. Those are the noble gases. They are super-duper stable with their completely filled shells. They are like dragons guarding their treasure. It takes a massive amount of energy to steal an electron from them. And what about the lowest points, the troughs? Those are the alkali metals. They have one extra electron and are actually desperate to just give it away to become stable. So it's very, very easy to take it. And our final cheat code is electronegativity. This is simply the electron pulling power of an atom when it's in a chemical bond. Just imagine two atoms playing a game of tug-of-war with a pair of electrons. The atom with the higher electronegativity is the stronger one, and it pulls those electrons closer to itself. So, who is the undisputed champion, the Bahubali of this electron tug-of-war? It is fluorine. A scientist named Linus Pauling gave it the highest score possible on his scale, a perfect 4.0. As you can see from the table, this power to pull electrons generally increases as you move from left to right across a period.
Okay, my dear students, we've gone through the whole story, the modern table, and all the cheat codes. Now, it's time for the slide you've all been waiting for. This is your final one-shot revision summary, the most important slide of this entire session. Ready?
Here you go, all the periodic trends in one simple, powerful diagram. The arrows clearly show you which way the size increases, which way electronegativity increases, everything. My most sincere advice to you, take a screenshot of this, right now. Save it on your phone, make it your wallpaper. I promise you, this one image is going to help you crack so many questions in your exam.
So please remember, mere pyare bachcho, the periodic table is not just some list of facts you have to memorize for your exam. Not at all. It is your ultimate tool. It's a map that, once you learn how to read it, allows you to predict the behavior of any element. Understanding the logic, that's the real power.
And with that, we are at the end. But I'll leave you with a little challenge. If tomorrow you read in the news that element 119 has been discovered, where would you place it on the table? Which group would it belong to? And, based on its position, what's one property you could predict about it? Think about it. You now have all the tools you need to figure it out. All the very best for your exams, bachchon. Study smart, stay confident, and I will see you in the next one.